questions 1 through 10 on the 2010 grade 10 AMC 10B. What is the value of this equation? Well, we have 100 times 100 minus 3, and then we have 100 times 100 minus 3. So obviously the order of operations is going to be important in this question. The first one, it would just be 97 in the brackets. And the second one, we have to do this first. So I think that's the only real trick in the question. And that, of course, is 10,000 minus 3. So this one is going to be 9,700. And this one is 9997. And therefore, if you do that subtraction, you get minus 297. Therefore, number 1, the answer is C. Makayla attended 2 meetings during her 9-hour workday. The first meeting took 45 minutes and the second meeting took twice as long. What percent of her workday was spent attending meetings? Well, we have to change this 45 minutes to hours because they're comparing it to 9 hours. And that's no problem. 45 minutes in hours is 3 over 4 hours. And then her second meeting took twice as long. So it would be 2 times 3 over 4, which is 3 over 2. So when you add those, that is the sum of the time that it takes her to attend those 2 meetings. And then we have to divide by the full hours in the day that she worked, 9. So this is going to be getting a common denominator, 3 plus 6 over 4 over 9. And that is 9 over 4. Invert and multiply 1 over 9, and that is 1 over 4. A quarter, which is 25%. So number 2, the answer is C. A drawer contains red, green, blue, and white socks with at least 2 of each color. What is the minimum number of socks that must be pulled from the drawer to guarantee a matching pair? We have red, green, blue, and white. We have 2 of each. So, as always, we're trying to do extreme case scenarios. So, when we fill out a sock, we'll try to pull out in a way that we don't get a matching pair, right? Because we're trying to see what can happen if we have this sort of an extreme case scenario. So, let's say we pull out a red sock, a green sock, a blue sock, and a white sock. So far, we have 1 of each color, no matching pair. But the very next sock, no matter what we choose, will be resulting in a matching pair, right? Because at this point, we only have 1 of each left, so we have to choose 1 of them. So, for example, if I chose a red one, they'd be a matching pair. So that means that I chose 5 socks, and if I chose those 5 socks, I'm guaranteed a matching pair. So number 3, the answer is C. For a real number x, define heart x to be the average of x and x squared. What is heart 1, heart 2, and heart 3? Well, heart 1 will be 1 plus 1 squared divided by 2, using this definition. Heart 2 would be 2 plus 2 squared divided by 2, and heart 3 will be 3 plus 3 squared divided by 2. So this is going to be, let's see here, 1 plus 6 over 2 plus 12 over 2. And that is 1 plus 3 plus 6, and that is 10. So number 4, the answer is C. A month with 31 days has the same number of Mondays and Tuesdays. How many of the 7 days of the week could be the first day of the month? All right. Well, let's just draw ourselves a little mini calendar here really quickly. And let's say the first day of the month, we actually don't know, but we do know this important clue that we have the same number of Wednesdays and Mondays, but they don't tell you how many though. So let's try extreme case scenario. Let's try to see if we can fit in 5 of each. And I think I can. You can just add 7 to get these numbers instead of having to write every single one out. And if I do that, there we go. It's 31. So just like that, I fit in, and I can just write these in if I really wanted to, the days that are Wednesdays. And as you can see, if I do it like that, there's 5 Mondays and 5 Wednesdays. So the first, let's see here, the first day of this month. So the first day of this month, if I did it like this, is obviously a Monday. They're saying how many such possibilities are there? So what we have to do really is just kind of shift this. And the condition is that you have to have the same number of Mondays and Wednesdays. Okay? I think I can do that. If I shift this a little bit, I'm going to obviously get a scenario where there's 4 Mondays and 4 Wednesdays, because this is the only way I can get 5 and 5 for the Wednesdays and Mondays. Now if I want 4 and 4, I can shift it like this. I can put the first of the month here, second here, third here, fourth here. And if I do that, this will be 11, 18, and 25. This is 6, 13, 20, 27, and then the 31 is here. So as you can see, there's 4 Mondays and 4 Wednesdays. So the first of the month in this scenario was a Friday. What I can do is I can also shift this a little bit. So instead of writing this all over, I can shift this where the month is just shifted 1 day behind. So this now becomes my new 1, this now becomes my new 2, and so on. If I do that, I retain the fact that there's going to be 4 Mondays and 4 Wednesdays. But if I shift to a Wednesday, then everything gets lopsided. It doesn't work anymore. So if the first of the month is shifted 1 day before, then the Thursday becomes the first of the month. So Monday, Thursday, and Friday are the only possible ways to have the same number of Mondays and Wednesdays. So the number of days that could be the first day of the month to meet the conditions of the question are 3. Monday, Thursday, and Friday. So that means number 5, the answer is B. A circle is centered at O, and AB is the diameter, and C is a point on the circle with COB equal to 50. What is the degree measure of CAB? So let's draw the diameter. Let's say that's the diameter right here. And C is a point on the circle. So we're going to make an angle of 50. So approximately here. So let's label this now. We've got A here, B here, and this is O, and this is C. So COB, this angle is 50 degrees. And what they want you to figure out is the degree measure of CAB. So CAB is that angle right there, right here. I'll just call that theta. Now, there is a formula that the central angle is twice any inscribed angle. So, for example, our arc in this case is CB, right? And our central angle is 50, right there. And the central angle is twice any other angle that's inscribed. So the other angle that we have inscribed subtending from the same arc CB is theta. So 50 is basically twice theta. And that's it. That's how you figured it out. So that means theta is 25. So number 6, the answer is B. A triangle has side lengths 10, 10, and 12. A rectangle has a width of 4 and an area equal to the area of the triangle. What is the perimeter of the rectangle? So we've got some triangle. Obviously, it's an isosceles since we got 2 sides that are the same. So something like that, right? So obviously, these two all make the same. So that's 10, and that's 12. Then we have some rectangle that has a width of 4. So that means this is 4. Length, I don't know. But they are saying that the area of this triangle is equal to the area of the rectangle. So that means 4 times L is equivalent to 1/2 base times height for that triangle. But base is no problem, that's 12. But what's the height? Well, obviously I've got to do a little bit of math to get that height. And I'll just draw a perpendicular like that. And there we go. This is a perpendicular. So that perpendicular cuts the base in two. So that means this will become 6 and 6. And this height I can easily get with Pythagoras. 8 squared plus 6 squared is 10 squared. So that means 8 squared is going to be 100 minus 36, which is 64. And therefore h is 8. So there we go. 4 times L is equal to 1/2 base, which is 12, times height, which I just got was 8. So let's see here. This is going to be L is equal to 6 times 2. So L is 12. And what do they want in this question? They want the perimeter. Okay. Perimeter obviously is 2 times the width plus 2 times the length. The width is 4. The length I just calculated was 12. So that looks like 8 plus 24, and that is 32. So number 7, the answer is D. A ticket to a school play costs X dollars, where X is a whole number. A group of 9th graders buys tickets costing a total of $48, and a group of 10th graders buys tickets costing a total of $64. How many possible values are there for X? Okay. So $48 divided by X is some integer, right? Because it's a whole number. And then again, $64 divided by X is some whole number. And N1 represents the number of 9th graders, and N2 represents the number of 10th graders, right? So 48, you have to break it down into prime factors, right? 48 is 1 times 2 times 2 times 2 times 2 times 3. And then 64 is just 2 to the power of 6, right? Yeah. So we have to just fiddle around with this and figure out what possible integer values can X have for both N1 and N2 to be integers. And if you do, you'll get that X can be either 1, 2, 4, 8, or 16. These are the only values that will work. And therefore, there's 5 values for X, and therefore number 8, the answer is E. Lucky Larry's teacher asked him to substitute numbers for A, B, C, D, and E in the expression right here and evaluate the result. Larry ignored the parentheses but added and subtracted correctly and obtained the correct result by coincidence. The numbers Larry substituted for A, B, C, and D were 1, 2, 3, and 4 respectively. What number did Larry substitute for E? Basically what they're saying is that he took this expression and instead of doing it properly, which is looking at the parentheses, he just ignored the parentheses and just did it like this: A minus B minus C minus D plus E. So he dropped the parentheses and just did it straight. But somehow he got the right answer. So that means that if I substitute these numbers for A, B, C, and D into both of these, they will end up with the same result. So let's do that. Let's do this one first. I think it's faster. We have 1 minus 2 minus 3 minus 4 plus E. And that's going to be 1 minus 9 plus E. And therefore that is minus 8 plus E. So this minus 8 plus E is going to be equivalent to whatever answer we get over here. Okay, this one we need to do a little bit more carefully here because we have to take the parentheses into consideration. There we go. All right, a whole bunch of parentheses. All right, so let's see here. This one is going to be 3 minus 4 minus E when you take it out of the brackets. Then this is going to be 2 minus 1 minus E. And then 1 minus 2 minus 1, so plus 1 plus E. And therefore this is 1 minus 3 minus E, and therefore that is 2 minus E. So 2 minus E is equivalent to this guy right here. So we can do that in this part. 2 minus E is equivalent to negative 8 plus E. put the... Sorry, this should be negative here. Aha! I'm not as lucky as Larry, I guess. So this is minus 2. Sorry about that. So if you put this e on the other side, you get 2e. Add 8 to that side, and you get 6. And dividing through, you get e equal to 3. So, number 9, the answer is D. Shelby drives her scooter at a speed of 30 miles per hour if it is not raining and 20 miles per hour if it is raining. Today she drove in the sun in the morning and in the rain in the evening for a total of 16 miles in 40 minutes. How many minutes did she drive in the rain? So for this question, we will use the formula speed is equal to distance over time, and any helpful variation like time is equal to distance over speed. So we have the time in the morning, which is when I guess it's sunny, and then the time when it's raining. And they tell you that total time is 40. So I've got to convert that to hours since we're talking in terms of miles per hour. So that is 40 over 60, and that is 2 over 3. All right. So each of these I will calculate with this formula, d over s. So we have the distance that she drives when it's sunny over the speed, which is 30, right? Yeah. And then we have the distance that she drives when it's raining over the speed, which is 20, and that is equal to 2 over 3. But we also know that the distance that she drives when it's sunny and the distance that she drives when it rains total 16, because they tell you that in the question. So I can substitute for 1. So instead of ds, I can write 16 minus dr like that over 30 plus dr over 20 is equal to 2 over 3. Right? So now we just have to solve for dr, and then we can eventually solve for the time, which is the time that when it's raining, so this right here. All right, solving for this, I guess we just have to multiply top and bottom here by 2 and 3 to get a common denominator. So that'd be 32 minus 2 dr plus 3 dr over 60 is equal to 2 over 3. So 32 plus dr over 60 is equal to 2 over 3. And therefore, if we cross multiply, we will get 96 plus 3 dr is equal to 120. 3 dr is equal to 24, and therefore dr is equal to 8. And that allows me now to figure out this time, the time which is tr, the time that she takes to drive while it's raining. And that's dr over 20. So that's 8 over 20. And this is in hours, and they want it in minutes. So multiply top and bottom by 3, and you get 24 over 60. And that is 24 minutes, basically. 24 minutes. So number 10, the answer is C.